Welcome back, class. It's Mr. Cabellin here, and I'm here to present the second lesson for Chapter 7, which is going to be dealing with one of three types of factoring, dealing with this in this course here. So we're going to deal with that in today's lesson. And before I begin here, what you probably want to have, and just a piece of advice here, if if multiplication tables is something you have difficulty with, what you could do here is go on the web, just Google and just look out for a multiplication table sheet, okay, and have it handy because it will be very, very useful for the lessons for the remainder of this particular chapter here. All right, so just keep that in mind. And if multiplication tables is something that you're good at, okay, you know what? There should be no issues whatsoever. So again, that's just something that I'm just going to throw up for you as we go through this particular chapter here. All right, so today's topic, like I said, is going to deal with common factoring. And what this is going to involve here is actually one of the first backward procedures that we're going to look at in this particular chapter here. So what do I mean by that? Well, remember the last lesson when I introduced you or reintroduced you to the distributive property? Okay, remember in this example here, and this is the exact example that we did in the last lesson, is that when I took the 2, okay, I multiplied to the x and I multiplied to the 4, and it gave me 2x plus 8. So you're probably asking, well, what does this have to do with today's lesson? Well, common factoring is the backwards of this process. So in this case over here, what you're going to wind up doing is we're going to start off with this, the 2x plus 8, okay, and you're going to learn how you can wind up with this, all right? That's why when I go through this particular topic, I always ask people that if they need a multiplication table sheet, okay, they should have it handy. It's in front of them for the lessons because it's going to make things a little easier to understand when we are, quote, working backwards here, all right? So that's just a basic example of what common factoring is, and I'm going to go through the steps in detail and how to figure out how in the world we're going to do that. All right, so let's get straight to it here and let's go to the PowerPoint. So today, like I said, we are dealing with common factoring. Now, as I mentioned earlier, this is one of three different types of factoring that you'll be looking at in this chapter and that what you will be revisiting in the next chapter as well. All right, so what exactly is common factoring? Well, common factoring, the first step that you're going to do here is to find what's called the greatest common factor. And what a greatest common factor is, okay, is a number, okay, a number, a letter, or a combination of the two that goes evenly into each term in an expression. Okay, so that's why when we're looking at the each question we're going to look at today, we're going to break it down step by step. So you look at both the number and if we need to, a letter. All right, so we're going to be dealing with that. And basically what we have to, as I said before, the greatest common factor is something that goes evenly into each term in a question. All right, and basically what we're going to see here, as I said before, it's a number or a letter or a combination of the two. So that when we involve ourselves with letters, we do need to take a look at it a little bit more carefully, because what you're going to see here is that there is a way to figure out what the letter will be as part of the greatest common factor when you look at the questions here. So once we see some numbers, I think it's going to become a lot clearer. All right, and let's get this started here. All right, so for the first example, we're just going to do a quick warm up here. And what we want to do for each question is just to take a look at what the greatest common factor is. So it says here, find the greatest common factor for each set of terms. So what you want to do here is to look at the terms given to you and then figure out what number goes evenly into both. All right. So for this first one over here, if you take a look at 3x and 15, let's first take a look at the number. Okay, so you have to ask yourself what number, other than 1 of course, goes evenly into 3 and 15. All right, well first off, let's start off with the two numbers I have here. All right, so can 3 go into 3? Well, sure, because it's 3. Okay, does 3 go into 15? Okay, the answer to that, yeah, it does. Now, if we go and we look at the 15, does 15 go into 3? Okay, answer to that is no. Okay, and the only thing that goes into 15 based on these two numbers is 15. So the greatest common factor number-wise will be 3. Now, you notice that the 3 here has an x, but the 15 doesn't. Anytime you have terms and only one of the terms has a letter, okay, you do not include the letter as part of the greatest common factor. So the greatest common factor of 3x and 15 is just going to be 3. All right. So again, on the right side there, I just have some quick little tips there on how to find the greatest common factor. And again, just as a reminder, this is the important part here. So I'm just gonna circle it in red over here. So remember, the greatest common factor is a number, a letter, or a combination of the two that goes evenly into each term in a question. All right. Now, this next one might be a little bit tricky. So for the first one, for the second one here, we have 10x squared and 25x. Let's first take a look at the number. Okay, so when you look at 10 and 25, okay, there's actually a couple of numbers that can potentially go into both. Okay, so for example, if you look at 10, for example, 10 goes into 10. Okay, but it doesn't go to 25. So we know that 10 isn't going to be the greatest common factor. If you look at the 25, okay, 25 doesn't go into 10, and the only thing that goes to 25 based on these two numbers is 25. So we're pretty much stuck. All right, now remember, other than 1, okay, we have to find other numbers that can go into 10 and 25. All right, so let's start at the very bottom. Let's start with 2. Okay, so 2 goes into 10, okay, 5 times. Okay, and however, 2 doesn't go to 25. All right, now 3 is an odd number and doesn't go to any of those numbers. And same thing with 4. 4 doesn't go to any of those numbers either. So the only possibility that we have, well, you guessed it, it's 5. Okay, because 5 goes to 10 twice. Okay, and then 5 goes to 25 5 times. All right, now you notice in this question over here, both terms, okay, both the 10x squared and the 25x have an x. So we do have to have a letter as part of the greatest common factor for this one. Now this is where the second rule down here applies. Okay, so it says here, when finding the greatest common factor of a variable term or a term with a letter, we always use the exponent with the lowest value. So between 10x squared and 25x, the variable with the lowest exponent would in this case would just be the x. So for the greatest common factor here, it's going to be 5x. All right. Now, if you have trouble understanding that first, okay, just get more practice with it. Okay, feel free to rewind in this video and just listen to that example again, because it does help to look at different types of questions so you understand how to find the greatest common factor. All right. Now, I put a star beside this one because there's a this is one of those twists to the rules that in math that you just have to just be careful with. All right. Now, let's take a look at the number here. Okay, and for now, well, let's ignore the negative that's in front of 4. Let's just focus on 4, 12, and 20. Well, for 4, 12, and 20, there's actually a couple possibilities for this particular question here. So 4, 12, and 20, they're all even numbers. So we know that 2 goes into all of them. All right, so 2 is a possibility. Now, 3 doesn't go to any of those numbers. However, 4 also goes into all 3 terms there, because 4 goes into 4, 4 goes into 12, and 4 goes into 20. So we have 2 choices. So you're probably asking, well, which of the 2 choices do we pick, 2 or 4? Now, this is where the word greatest common factor comes into play. Greatest is referring to the highest of those 2 numbers, which in this case here would be 4. So 4 goes into 4, 4 goes into 12, and then 4 goes into 20. So we've established that 4 is part of the greatest common factor. All right. Now, if you take a look at the letters, notice that every term here also has a letter. It has the letter x. The only difference is that we have an x cubed, an x squared, and an x. So just like the previous example, you always pick the letter with the lowest exponent, which in this case here would just be the x. All right. So right now we have a 4 and the x, which are part of the greatest common factor. Now here's a twist to the rule over here. Okay, when you have a negative attached to the letter with the highest exponent, you also have to include that as part of the greatest common factor. Okay, and once we get to this example, I'll explain why. All right, so that's why I've written that there. So when you, in this case over here, not only is the greatest common factor going to be 4x, but it's actually going to be negative 4x. All right. And like I said, we're going to see these numbers again in the next slide over here, and I'll tell you why that has to be the case when we're dealing with the highest, the variable with the highest exponent. All right. Okay, that's just the warm up of the way. So let's actually take a look at some problems here. All right, so we're actually now going to take a look at common factoring, and as you can see, I've used the exact same numbers, okay, from the warm up, so that you can see how to approach these kind of problems when you actually get to see them. All right, so if you take a look at what we have here, let's bring the set of instructions first. Okay, so what we have to do here for the first step is to determine the greatest common factor. Okay, and whatever that is, you put it in front of the set of brackets that you see on the screen here. So greatest common factor of 3x and 15 from the previous slide was 3. Okay, so we're going to put the 3 in front here. Now, the step number 2, and this is the part you need to pay very close attention to. The idea of common factoring, okay, is to divide each of the terms there by the greatest common factor. So if you take a look at what I'm going to do here, okay, I'm taking the two terms, I'm going to divide both of these terms by 3. Now, the way I've done it here makes you see exactly what's happening when you do that particular step. So remember that now these two 3's, they cancel out and they give me x, and then 15 divided by 3, that's going to give me 5. So the final answer for this will be 3 and in brackets x plus 5. All right. Now remember, when we're doing the distributive property, just do a check over here. If I multiply this 3 to the x, it'll give me 3x. And then when I multiply this 3 to the 5, it'll give me 15. So that's just a way to check to see if you have the right answer or not. Okay, for part B, we have 10x squared minus 25x. And remember from the previous slide over here, we determined the greatest common factor for this one to be 5x. All right, so we're going to put it in front instead of the brackets here. Now, in this one over here, we're going to divide both the terms here by 5x. Now, I want you to see what's going to happen in the next step here. Okay, let's start off with 10x squared and 5x. Okay, so what we're going to do first is 10 divided by 5, which is 2. Okay, so we have to factor in that we're also still dividing the numbers that are in front. Now, this is the part that that might be hard to understand at first. Okay, if you have an x squared here, okay, on the top and an x on the bottom, okay, you're basically subtracting the exponents. Okay, so that's probably the best way to do it. So if I have an x squared over here and I'm dividing it by an x on the bottom, what we wind up getting there is x. So altogether over here, we get an answer there of 2x. Okay, because 10 divided by 5 is 2, and then x squared over x just gives me the x. All right, now this next one over here, negative 25 x over 5x. So remember, we have negative 25 divided by 5, which gives us negative 5. Now, this is an easier one to understand. If you have two x's that are the same, okay, these two here, notice that they're exactly the same here. They just cancel each other out. So what we wind up getting here would just be negative 5, okay? So what I want you to see here is that when you are dividing and a letter is included, okay, if especially this first one here, the x squared and the x, okay, just remember if you have a letter with an exponent and the one below it has it's just the variable by itself, okay, you're just reducing the value of the exponent. Okay, so we're going to see that another example of that in the next one over here. Okay, so for this one over here, remember this is the special case here where the greatest common factor had the negative in front. And the reason for that is because the variable or the letter with the highest exponent, that's where the negative was. Now, I mentioned when we did the warm-up for this, there was a reason for that, and this is the reason why. Okay, so don't forget to put the greatest common factor in front of the brackets, and let's divide each greatest common factor here by negative 4x. Now, the purpose of making the greatest common factor here negative is because if you take a look at the first term here, the negative 4x cubed over negative 4x, okay, these two negative 4's, okay, cancel out, and we wind up getting a resulting answer that winds up being positive, which is what we want. Okay, so notice that for this one we have x cubed, okay, and we have an x on its own. So remember that these x's over here have the quote invisible one. So if I have x cubed over here and I have an x over here, well, as I said before, you're basically subtracting the exponents. So this will give me a value here of an x squared here. All right, so I'm just changing the signs here just as a reminder that what we have to do here are the rules of integers. So these two negative 4's cancel out. Okay, we have an x cubed here and an x over here, which gives me x squared. All right. Now this one over here, we have 12, and we're going to divide it by -4, so that's -3. Okay, and if you take a look at this x squared over here, and this is an x, so we have an x remaining on its own. So altogether, we have -3x. And last but not least, we have two negatives that become positive here. Okay, and the two x's over here, since they're the same, they just cancel out. So the final answer will be -4x, and in brackets, x squared minus 3x plus 5. All right, so in terms of common factoring, that's probably as hard as it gets there. Just remember that if you have variables in each term or letters in each term, you pick the letter with the lowest exponent, which in this case here is the letter by itself, which has the invisible one. Okay, so I hope, again, that you see how common factoring works. Like I said, it's the backwards process of the distributive property, basically. Okay, and again, just make sure if you're having trouble with the just figure out what numbers go into the terms. Okay, make sure you have a multiplication table sheet handy. All right, let's take a look at a word problem over here. So if you don't recognize that, that's a front cover to Future and Drake's album. And what we want to do here again is just to figure out the dimensions of the album cover here. So it tells us here the area of a CD case is represented by the binomial 16x plus 4x squared. So what we want to do here is to factor this out using common factoring. All right, so let's start off with the numbers. So if you take a look at 16 and 4, okay, as I said before, this has a couple of possibilities for this one. Now 16 and 4, okay, are even numbers. So that means 2 goes into both 16 and 4, all right? Now 3, okay, 3 doesn't go into 16 or 4, so 3 can't go in there, okay? But 4 goes into both 16 and 4. Now remember, when we're looking at the greatest common factor, you're picking the highest number possible that goes evenly into both. So between 2 and 4, the highest number there is 4. Okay, so number-wise, we know that 4 is going to be part of the greatest common factor. Now for this one over here, notice that the two terms also have a letter. So remember that when you have letters, you just have to pick the one with the lowest exponent. So between x and x squared, okay, x would be the one with the lowest exponent. So our greatest common factor here is going to be 4x. All right. Okay, and let's factor this out. So remember that you always start off by taking the greatest common factor, okay, and writing it in front of set of brackets there. Okay, so do that as we're going along. And what we're doing here is taking the greatest common factor and then dividing each term by it. So 16 divided by 4 is going to give me 4. And these two x's, since they're the same, they cancel out. So the first term inside the bracket is going to be 4. Okay, now this next one over here, these two 4's cancel out. Okay, so because they're both the same number. Now, since I have an x squared on the top and an x on the bottom, okay, you're basically, like I said, you're subtracting the exponents here. So we have an x remaining there. So that's the final answer to that. Okay. And if you want to, you can also leave out that 1 in front of the x. I just put it there for demonstration. So it says, using the expressions from A, which is this, determine the actual dimensions if x is equal to 5 centimeters. So what we know about this is that this here represents the length, and this one here represents the width. And we're just going to take these and substitute the 5 in for the x's. So starting off with the length here, with the length of 4x, okay, now remember that when you substitute a number in for a letter, you're just going to put brackets around it like this. All right, and then when you multiply these two numbers together, that will give me 20. So the length will be 20 centimeters. And last but not least, the width here will be 4 plus 1x. So all I'm going to do here is to replace the 5 in for the x like this. Don't forget, put the brackets around the 5. Okay, and if you carefully put that in your calculator, you should get an answer there of 9 centimeters. Okay, so again, common factoring is the opposite of the distributive property. Okay, so just think backwards. This is one of the backwards processes we're looking at here. All right, and last but not least, just an extension of the question. It says determine an algebraic expression for the perimeter using the expressions from A, which are right here. Okay, and substituting them into the formula given. So notice that the formula is given to us, and all we're going to do here is replace the length in for the L, okay, and the width here with the 4x plus 1. Now, just as a reminder, anytime you're replacing letters with numbers or terms, always put brackets around it. So when this 4x goes in for the L, I'm just going to put brackets around the 4x. Now, this one over here, when I replace this W, I'm going to replace it with a 4 plus 1x and put brackets around these two terms, like that. Okay, so what I want you to see is all I've done here so far is just substituted the letters with the terms that are that we found out in the previous question. All right, so 2 times 4x will give me 8x. Okay, and then we're going to multiply the 2 to the 4 and then 2 to the 1x, which is going to give me 8 plus 2x. Now, if you look at this expression carefully, you notice that we do have two things that we can group together. Okay, and in this case here, we're going to group together the 8x and the 2x. So 8x plus 2x is going to give me 10x. Okay, and then we have the 8 on its own there. All right, so that's just the extension to this problem here when we're dealing with just using the formulas and substituting the values into them. All right, so that wraps up common factoring. And don't forget to start practicing on the questions that are located in your review. Okay, and I will see you in the next lesson.